Good morning, ladies and gentlemen. We're going to start our last section of Chapter 14. We're going to solve some trig equations. We're going to do that by hand and in your grapher. So I will specify how I want you to do, which method I want you to use when we take a quiz or an exam. So let's just jump right in with some examples. The first one is going to say solve, and they're going to give you an interval from 0 is less than or equal to x is 2 pi. And basically what that means is I want to find the solutions within one rotation of the unit circle, and my equation is going to be 2 sine x minus radical 3 is 0. So just like regular equations, the first thing that I'm going to try to do is isolate the sine of x. So I'm going to take the radical 3 to the other side. So I'm going to have 2 sine x is equal to radical 3. Then I'm going to divide both sides by 2. And then I'm going to get the sine of x is equal to radical 3 over 2. So now is when we do this part by hand. So if you'll think about the unit circle, sine y is positive in two quadrants. It's positive in the first quadrant and it's positive in the second quadrant. Okay, so I'm trying to find those two angles. And I'm going to actually use a theta instead of an x because I think then it gets too confusing on what I'm actually solving for. So sine is y over the hypotenuse and y over the hypotenuse. So this angle opposite the opposite the radical 3 is a pi over 3, and then this angle is 2 pi over 3. So x is going to equal pi over 3 and 2 pi over 3. So there are often two solutions that will satisfy the same equation, and those would be my two solutions. So now I'm going to show you how to do it graphically. Okay, so we had the equation 2 sine x minus radical 3 is 0. And I'm going to write two different equations. So I'm going to go back to where I had solved. So I had the sine of x is equal to radical 3 over 2. So what I'm going to do is I'm going to graph two equations. I'm going to graph y is equal to the sine of x, and I'm going to graph y is equal to radical 3 over 2. This is my oscillating sine function, lovely graph, and then this one is a horizontal line. And so I'm going to find the intersection in this specific interval for this equation. So let me bring in my handy dandy grapher. I'm going to enter, so first you have to go to your mode and make sure that you're in function mode. See if you can see that a little bit better. Function mode and in radians, because you can't graph sine, cosine, tangent unless you're in radians. Okay, so if I go to my y equals, I'm going to enter the sine of x, and then I'm going to enter second radical 3 divided by 2. The next step that's important is I'm going to go to my window, and it wanted me to graph from 0 to 2 pi, so that's what I'm going to do. So I'm going to change my x min to 0, my x max to be 2 second pi, and then my y values, remember that y oscillates between plus or minus 1, so I'm going to change this from a negative 2 to a positive 2 just to make sure that I can see the tops and bottoms of my curves, and then I'm going to graph. Okay, so there's my sine curve in the interval from 0 to 2 pi, and there's the line y is equal to radical 3 over 2. So I have 2 points of intersection, this one and this one. So I need to find those. So I'm going to do second calculate 5 for intersect. And I am actually going to use my down arrow to get on the straight line because the shortest distance between 2 points is a straight line. Sorry. And then I'm going to do second calculate first curve enter, second curve enter, and then enter one more time. And I get that x is equal to 1.047. And then I'm going to write that value down, and I'm going to do it again. Second calculate 5 for intersect. Notice that it pops right back to the first equation that you entered. I'm going to use my down arrow because it's faster to trace a straight line. And I'm going to go over near the point of intersection, enter, 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 and I get that my second point is 2.094. All right. So if we end up with a special situation, we will be doing the math by hand. If we end up with a situation where a special triangle is not involved, then we'll be using our calculators, and I will always tell you which I want you to do. All right, So let's do another example, okay, by hand. Okay, so this will be our second example. And I want to solve, and I want to solve in the interval from 0 to 2 pi. Okay, shouldn't have, let me erase that little equal to, because we don't want to actually include 2 pi because then the value's repeating. And the equation is going to be 3 cosine x is equal to the cosine of x minus 1. So to be able to solve these by hand, I need my cosines to be together. So I'm going to subtract this cosine to move it over here. So I'm going to have 3 cosine x minus cosine x is a negative 1. 3 minus 1, I'm going to get 2 cosine x is a negative 1. Divide both sides by 2, and I get that cosine of x is a negative 1/2. All right, so we're still solving these by hand. So now let's think about our unit circle. Cosine is negative, x is negative, both in the second and the third quadrants. So my triangles could be here or here, okay? Oh, crappy triangle, sorry. There's my little right angle symbol. Both cosines, I'm going to put a negative 1, and then my radii or my hypotenuse are 2. So since it's opposite the negative 1, that means that this is a 30-degree angle. So if I go, let me explain how I would get my angle. All the way to here is pi, and if I make it be 6 pi over 6, so it's a multiple of a 30-degree angle, and I back up pi over 6, 6 minus 1, this angle is 5 pi over 6. Okay, and then let me get this angle. So I'm going to be adding and subtracting from my x-axis. So my first angle, I'll write it down here, is going to be 5 pi over 6. And then if I go to get to this angle right here, I go all the way to pi. I know it's a multiple of a 30, so I'm going to multiply pi by 6 over 6. And I'm going to keep going 30 degrees more, so I'm going to add pi over 6. 6 plus 1, I end up with 7 pi over 6. So my second angle by hand is 7 pi over 6. Okay? All right, so those would be my solutions doing it by hand. Let me show you how to do that one in your calculator. So we had the cosine of x is a negative 1/2. But this is a special, but I'm just going to show you how it would work if we were doing this math graphically. All right, so I enter my cosine of x as my one equation, cosine of x. Okay, forgot to close my parentheses, and then I'm going to go up here and I'm going to enter 1 divided by 2, and I am going to solve in the same interval. So I still have from 0 to 2 pi, and then I have a negative 2 and a positive 2, so I can see the tops and bottoms of my curves, and I'm going to graph. So there's the horizontal line. Oh, and I forgot. So let me go back, shame on me. I forgot to enter a negative 1 divided by 2. Now I'm going to get the right line. There we go. Okay, so there's my cosine curve. Remember, cosine starts high, finishes high. So here are my 2 points of intersection. So I'm going to do second calculate intersect. Notice that I entered the horizontal line first, so I can trace that pretty easily. I usually start on my left so I don't forget a point. And I get x is equal to 2.094. Notice that the y is a negative 1/2, and it should be because we entered a horizontal line. Find the second point, second calculate intersect. And again, I'm going to trace my horizontal line because the shortest distance between 2 points is a horizontal line. Enter, enter, enter. And my second point is 4.189. So those would be my 2 solutions if I were doing it graphically. Okay. Couple of key words to remember. If you see the word find the exact solutions, that means that you have to do this by hand. Okay? If it just says find the solutions, that means that you get to use your grapher, because that means that it's okay to round your answers off. All right. I have one more example, and then I'll give you your problems. Okay? This one again says to solve, and I want to solve in the interval from 0 is less than 2 pi, so 1 complete rotation of your unit circle. Okay? And I'm going to solve 5 plus 2 sine x minus 7 is 0, and I lied. I have one more example after this one. Sorry about that. So the first thing that I'm going to do is I'm going to try to get the sine of x by itself. So I'm going to take the 7 to the other side and the 5 to the other side. So I'm going to get the 2 sine of x is equal to a positive 7 minus 5, which is 2. I'm going to divide both sides by 2, and I get that the sine of x is equal to 1. Okay, so now let's go back and talk about our unit circle. Okay, anytime sine and cosine are 1 or a negative 1 or 0, that means that we're using one of our quadrantal angles. Okay, so remember sine is 1 at pi over 2 and not at 3 pi over 2, because down here it's 0 negative 1 and up here it's 0 positive 1. So the only place that sine is equal to 1 is at pi over 2. So x is going to equal pi over 2. And I'm not going to do the graphical solution because this is a special. All right, now for the last example. Okay, so this one's going to say solve. And again, we're still going in the interval from 0 is less than or equal to theta less than 2 pi. And we're going to do this one again by hand, because I will do the majority of your problems on a quiz or test by hand. So this time I'm going to have 3 tangent x minus radical 3 is 0. Again, my first task is to isolate tangent, so I'm going to take the radical 3 to the other side. So I'm going to have 3 tangent x is equal to a radical 3. Now I'm going to divide, whoops, that's supposed to be a 3, both sides by 3, and I get the tangent of x is equal to radical 3 over 3. And remember, if I unrationalize this is going to be 1 over radical 3, okay? Because this is easier to manage my math. Now I'm going to draw my unit circle. Tangent is positive in the first quadrant, and it's positive in the second quadrant because both values are negative. Tangent, if you will remember, is y over x, so that's going to be 1, and then my x is radical 3. This is a negative 1 and a negative radical 3. Oops, sorry, put it in the wrong spot. Negative radical 3. So that's why this one's positive, because the two negatives cancel. Okay, so if this is opposite the 1, this is going to be pi over 6. And then if I go all the way to pi, so if I do pi, it is going to be a multiple of pi over 6. I'm going to multiply by 6 over 6. I'm going to go pi over 6 more, and I'm going to end up with 7 pi over 6. So my two solutions are pi over 6 and 7 pi over 6. All right, so really not a difficult concept, but you do have to remember your values. Oh, and I still lied. I want to show you, sorry, my bad. I want to show you an example using factoring. And I actually want to show you 2 examples using factoring, so my bad. We're almost done. All right, so this one's going to say solve use factoring. Solve using factoring. So one of these days I'll get my act together. Your equation is going to be the sine cubed of x minus the sine of x is 0. And again, we're going to solve in the interval from 0 to 2 pi. Alrighty, so the first thing that I'm going to do in my particular equation is notice that they both have a sign in common, so I'm going to factor it out. So I'm going to pull out a sign, and I'm going to be left with sine squared x minus 1 is 0. So remember, the purpose of factoring is to create 2 baby equations that I can then solve. So here are my 2 baby equations. I have the sine of x is equal to 0, and I have sine squared x is equal to 1. Okay? All right, so this one's done. This one, I need to take the square root of both sides, and I get the sine of x is equal to plus or minus 1. Alrighty, so now I'm going to do my unit circle for this one. Sine is 0 over here, so this is the point 1, 0, and this is the point negative 1, 0. So from this particular factoring baby equation, I get that x is equal to 0 and pi. And then if I go to this one, and I draw my little unit circle, okay, sine is a positive 1 up at the top, so this is 0, 1, and that's going to be at pi over 2. Down here at a 0, negative 1, remember sine is y, this is 3 pi over 2. So my other 2 solutions are pi over 2 and 3 pi over 2. So those would be my solutions. All right, last example for real this time. Again, it's going to say solve using factoring. Got to get my grammar in there. And again, I'm going to solve in the interval from 0 to 2 pi. So one complete rotation of the unit circle. Okay. All right, and this one's going to say cosine cubed x is equal to the cosine of x. That's what we're going to start with. So since I'm trying to solve for cosine, I'm going to put all of the cosines on the left-hand side. So I'm going to have cosine cubed x minus the cosine of x is 0. These two guys both have cosine in common. Factor it out. And I'm going to get cosine squared of x minus 1. Okay. Now I have my two baby equations, so I'm going to set the cosine of x is equal to 0, and I'm going to set the cosine squared of x minus 1 is 0. Manage this one a little bit more, so cosine squared x is 1. Take the square root of both sides, and I get the cosine of x is plus or minus 1. Alrighty, so now let's solve using our unit circles. Okay, cosine is 0 up here at pi over 2 because the coordinates are 0, 1, and down here at 3 pi over 2. Okay, so I'm going to get x is equal to pi over 2 and 3 pi over 2. That's from my first unit circle. From the second one, here's my unit circle. This point has coordinates 1, 0, so this is 0 radians. And then this point over here is a negative 1, 0, and at that point my angle is theta, or sorry, pi. So now I'm going to have 0 and pi. Those would be the 4 different places that satisfy my equation. Alright, so now let me give you your problems. Sorry, that was a little bit bad on my part. Alrighty, here are your problems. They're all going to say solve by hand, of course, because that's easier. And I want you to solve in the interval from 0 is less than or equal to theta is less than 2 pi. So that just means one complete rotation of your unit circle, and you must draw the diagram. And so I'll say draw the related diagram. And just like we did when we started our unit circle, it's really important to do your labeling. So your first equation is going to be 2 cosine x is equal to the cosine of x minus 1. Your second equation, 2 sine x minus 1 is 0. Your third equation, 2 sine squared x minus 1 is 0. Is that one going to work? Plus, yes it is. And then number 4, you're going to have 4 cosine squared x minus 1 is 0. And then I have one more, kind of a bonus one. 2 sine cubed x is equal to the sine of x. Okay, and then on this one you need to remember, and on these three actually, remember that if I have to take the square root of both sides, I have two potential solutions, plus or minus. Alrighty, good luck with your problems, and I will see you tomorrow.